Welcome back to this live lesson series in coordinates and straight lines. Today we'll be continuing our work on coordinates and straight lines, looking at how do we draw a straight line given a table. Hopefully you've managed to have a go at these starter questions. As always, we will start by going through the solutions to these. And if we focus on the first question in the top left box, where you were asked to generate the first 5 terms of the sequence 7n minus 5. And hopefully you've watched my sequences series and are familiar that to generate a sequence, any term that you need represents n. So if I want the first term, n is 1. So you have to substitute n is 1 into our nth term, so that would be 7 multiplied by 1, which is 7, minus 5, which is 2. So that means our first term is 2. And we could do the same for the second term. We could say that n is 2. Substituting n is 2 into our nth term, 7n minus 5, would give us 7 lots of 2 minus 5. So that would be 14 minus 5, which equals 9. Now, if you have watched the series, you'll know that whatever is in front of the n, in this case 7, is what the sequence is going up in. And as you can see, the difference between 2 and 9 is 7 plus 7. Which means to get the next successive terms, instead of having to substitute in n is 3, n is 4, n is 5, I can simply add on 7 because I know that this sequence is going up by 7. So adding 7 to 9 would give me 16. Adding 7 to 16 would give me 24. And adding 7 to 24 would give me 31. And if you're unsure, you can always check if that works. What term is the 31? That would be the first, second, third, fourth, fifth term. So for the fifth term, n is 5. If I substitute n is 5 in, I'd have 7 lots of 5, which is 35, minus 5 is 31. So that gives us the correct answer. So there's 2 methods that you could answer that. Hopefully you use the add 7 method once you found the first term, because that is the most effective method and the one that we discussed in sequences. If we have a look at this fraction question next, first thing we should check, what is the operation? The operation is divide. When we divide fractions, we should think K, C, F. Remember, keep, change, and flip. But before we can do that, before we can keep, change, flip, we must realise that these mixed numbers need to be changed into improper top-heavy fractions, so we should do that first. And by doing that, that would give us 3 times 2 is 6, plus the 1 is 7. So that would be 7 over 3 divided by 5 times 3 is 15 plus 2 is 17. Now if you're unsure about how I'm turning this mixed number into a top-heavy fraction, you can look at my fraction series where I go in depth about how to do that and why it works. Now we can use keep, change, flip because we have these as standard improper fractions. So if I keep, I would leave it as 7 over 3, change the divide to a times, and flip, do the reciprocal of the last fraction, would give me 5 over 17. Now multiplying fractions is the easiest one of them all. You can simply multiply straight across. So we'll do 7 times by 5 is 35. And we can do 3 times by 17 is 54. Okay. Can we simplify that? Can we think of a number that goes into 54 and 35? I don't believe there is, so we would leave that as 35 over 54. Hello, Ethan. So, drawing lines. This is something that we looked at last lesson in coordinates and basic straight lines. We looked at how do we plot coordinates, how do we find midpoints, and we looked at how do we plot x equals and y equals graphs. Now, I've asked you to draw x equals 3. Hopefully you can recall that the line x equals 3 is where x is always free for any y, okay? Or more simply, it is where a straight line crosses through the x-axis at 3. So where would a line cross through the x-axis at 3? It would be x-axis is 3 there. It would be a line that goes straight through there. And as you can see, for any point of y, if y is 1, x is 3. If y is 2, x is 2. If y is 2, x is 3. Sorry, x is 3 for y is 2. So we can simply draw a line that goes directly through x is 3. And we can call that x equals 3. And if you're unsure about this, you can go back and check that lesson. Y equals minus 2 is a line that goes through the y-axis at minus 2. So a line that goes straight through the y-axis at minus 2. Okay. So that would look just like this. A line that goes straight through the y-axis at y equals minus 2. And then finally, where x is 0. Now we discussed this. When x is 0, that is a line that goes through the x-axis at 0. Now 0 is the origin, so if I put a line that goes through the x-axis there, I am in fact just drawing, and hopefully you can see that, I am just drawing the y-axis. Okay, so x is 0 is simply another way to write the y-axis. And similarly, y is 0 would be the x-axis. Okay, so hopefully you managed to follow along there or mark the questions that you did yourself. This takes us on to the actual contents of today's lesson, which is drawing lines from a table. Now, drawing lines from a table is always going to use something called the equation of a straight line, or a quadratic, or a cubic graph. Today we'll be looking at only straight lines, and we'll be looking at how do we use the formula for a straight line with a coordinates table to plot it nicely on a grid. Okay, so how do we do that? Well, the first thing we should do is just explore what example 1 is asking us. It says complete the table for y equals 2x plus 2. So this is the equation of our straight line, which we are going to go into more in further lessons. But that is the equation of a straight line. So we'll just add that note. It's the equation of a straight line. And as you can see, what does it say? It says y equals 2x plus 2. So the y and the x, what do you think that stands for? Well, hopefully, if you give a little bit of thought to what we're doing drawing straight lines where you get put those on a coordinate grid. So the x and y actually stand for coordinates. The x is the x coordinate, and the y is obviously the y coordinate. Okay, why is that useful? Well, that means that I can substitute values in for x or y to get the other one. So this is a equation with two unknowns, and if I replace one of these unknowns, and we have looked at substitution with the sequences stuff, question 1 on the starter was substitution, and replace the x, for example, with a number, we can then work out what y is. And if we got x and y, what do we have? We have a coordinate. Okay, if we got x and y, we have an x and a y coordinate. And what do we do with coordinates? We plot them. So we can use this equation, which is the equation of a straight line. We can use some x coordinates that they've given us in a table. Yeah, we can see here that these are x. This whole row here is x. So x is -2, -1, 0, 1, 2, 3. We can use those, put them into our equation, and it's going to tell us what y equals, because it says y equals 2 lots of x plus 2. So if I do 2 lots of x and add 2 to it, it's going to give me y, which means then I've got a set of coordinates that I can plot, which we've done in the previous lesson. So I'll walk you through this. This table is what we call a table of coordinates. Okay, so we could add that note in. This is a table of coordinates. Why is it a table of coordinates? Because it's x and y, and we know coordinates are written as x and y. So let's have a look at how do I use my equation. They've told me that they want me to fill in -2 as x, -1 as x, 0 as x, 1, 2 and 3 as x. So I need to do that step by step for each of these numbers. So if we focus on the first part, let's have a look. What does y equal? They want to know, what is y when x is -2? Well, if I substitute in x is -2 into my equation over here, it says y equals 2 lots of x plus 2. Well, 2 lots of x, so that means y equals 2 lots of x, which in this case, what is x? X is -2, so that's 2 lots of -2 plus 2. So hopefully what you can see there is all I've done is replace the x in my equation with the x that I'm focusing on here, which is -2. Okay. So that equation, I've replaced my x with -2. Well, we can work that out now. 2 lots of -2, well, a positive times a negative is a negative. So that would be 2 lots of -2 is 4, but it'd be -4. And then I've got the +2 on the end. So what is -4 plus 2? So again, like a lot of topics in maths, if you don't have a really good understanding of positive and negative numbers, that's where you make the mistakes. The actual content of this isn't difficult. Where students make mistakes is not understanding or making silly mistakes on positive and negative numbers. But if we're careful, if we're starting at -4 on a number line and we're adding 2, where would that get us? It would get us to -2. So the answer for y here is simply -2. So I've replaced my x with -2. I've worked out my equation, simplified it, and I've got -2. So what is that? That is simply a coordinate, isn't it? It says x is -2, and I got y as -2 as well. So my coordinate is -2 for the x and -2 for the y. So let's put some colour on that so you can see where I've got those from. And we have to repeat this for the rest of the coordinates, and hopefully we might spot a pattern. So if we do it for the next one, when x is -1, so we're going to replace x with -1. So what would that give us? If we look at our equation, we're going to have y equals 2 lots of -1 plus 2. Well, what is 2 lots of -1? 2 lots of -1, a mixture makes a minus, so that would be -2 plus 2. Well, what is -2 plus 2? -2 plus 2 would be 0. So I can see that my y coordinate when x is -1 would be 0. So again, I've made another coordinate where x is -1 and y is 0. So we're making coordinates here, and we're going to plot them in a moment, and we're going to see that it makes a straight line. So what comes up next when x is 0? Well, that's the easy one. Y equals 2 lots of 0, because x is 0, plus 2. Well, what is 2 lots of 0? Anything multiplied by 0 is 0. 0 plus 2 is 2. So my y value for x is 0 is 2. Again, we have another coordinate now. That is 0, 2. How do I know 0 is first? Remember, x is first. X is first, always. X, y. Okay. Next. Now we're positive, it gets a lot easier. Okay. When you're dealing with negatives, you've got to be really careful, but when it's positive, it becomes a lot easier. When x is 1, well, y equals 2 lots of x, well, x is 1, 2 lots of 1 plus 2. 2 lots of 1 is 2, plus 2 is 4. So our y coordinate there would be 4. Again, we can write that as a nice coordinate, 1, 4. And you're probably starting to see a pattern right now. If you're looking at these numbers and seeing what's happening to them, you could probably see a pattern. And what's really nice about this is we can link it to the sequences stuff that we've seen in previous lessons. But we'll continue anyway, just so you can see where they all come from. When x is 2, well, what would that say? That says y equals 2 lots of 2, because x is 2, plus 2. 2 lots of 2 is 4, plus 2 is 6. And you might have already thought to yourself, I bet it's going to be 6, because you can see a pattern. And what is that pattern? The pattern is every time we go across 1 on the x, so these are increasing by 1, every time we go across 1 to the next coordinate, what's happening to the y? It's going up by 2. Well, this is an nth term, isn't it? 2x plus 2. Remember, whatever's in front of the n, or in this case the x, is what the sequence is going up by. So what's in front of the x here? 2. What's this sequence going up by? 2. So there's a nice link that we can make there. And once you spot that link, and once you understand that link, you can use it to fill out these tables much quicker. And we'll look at that in the next example. We'll finish this manually though by taking the x value of 3 and substituting it in. So we've got y equals 2 lots of 3 plus 2. 2 lots of 3 is 6. 6 plus 2 is 8. So you might have already spotted that it was going to be 8 because 6 add 2 is 8, but that's how I got it from using my substitution method. And you will always have to start with at least one substitution method. And then you can start to use that technique where we've seen the pattern of what it is going up by. Okay, so we now have some nice coordinates. So if we just write these last two as coordinates, 2, 6, and x is 3 and y is 8. We have some nice coordinates. So we can now read part 2. Part 2 says, on the graph, draw y equals 2x plus 2 for the values of x from -2 and -3. Well, what does this last bit mean? This last bit just means that x needs to be from -2 up to 3. So what it means is our straight line needs to go from edge to edge. That's all that means. Our straight line needs to go from edge to edge, not just a little line. It needs to make sure it spans the whole width of the graph. So let's have a look. Well, if I need to draw the line y equals 2x plus 2, I've just filled out a table of coordinates for that very same equation, which means I can simply take my coordinates and I can use them, plot them, and hopefully, if we've done it correctly, it's going to make a nice straight line. So let's start by plotting the first coordinate. The first coordinate is -2, -2. So if I start at 0, I'm going to go across -2 and then down to -2. So that would be this point here. -2, -2. If we take our next coordinate, -1, 0. I'm going to start at 0, always start at the origin. I'm going to go across -1 and I'm going to go up 0. That means I don't go anywhere. So my point will be on the x-axis at -1. Just to recap, I went across to -1 because x was -1 and y is 0, which means I stay exactly where I am. The next coordinate is 0, 2, so I start at the origin, I go across 0, so I stay where I am at, and then I go up 2. So it's going to give me that point there. And hopefully you can see that these points are starting to create a straight line. But my straight line needs to go all the way across to the edge up to 3 and starting at -2. So I need to keep plotting my coordinates. Next one, 1, 4. Across 1, up 4 there. And you can probably just start to see where these coordinates need to go to make a straight line. It's quite obvious. But just for clarity, we'll go for the next one. 2, 6, across 2, up 6. It's going to go there. Okay. The next one is 3, 8, across 3, up 8. So it's going to go here. So as you can see, we have made, and the best thing about these questions is, you know if you're right. If our coordinates were all over the place, okay, if our coordinates looked something like this, everywhere, that's not a straight line. And the whole goal of this is to draw a straight line. So you can actually see if you're going to be correct or not, because you can see that our points here make a perfectly straight line that we can connect. So the last step to solving this and answering this question is to draw a straight line with a ruler directly through these points to make your straight line. And this would be the line y equals 2x plus 2. So what have we done there? If we just zoom out and sort of look at the whole page, what we've done is we've taken a equation of a straight line, we've been given a table of coordinates where we had to fill in the y coordinates given the equation, so we've used a bit of substitution. We have to be careful with negative and positive numbers. From that, we've created coordinates. These coordinates, remember, can be plotted. So we've gone down to the graph, we've realised they're talking about the same equation, which means we can use the coordinates previously and we can plot them, and this creates a perfect straight line. And always use a ruler when drawing a straight line. So let's see if we can now take that little pattern we spotted where whatever's in front of the x, a bit like sequences, whatever's in front of the n is what the sequence or what the values are going up by in this case. The y values are going up by. We're going to look at how can we do that to speed this process up. So example 2. Complete the table for y equals 4x minus 2. So we've got the equation of a line where y equals 4x minus 2. And so hopefully you might already be thinking, 4 is in front of the x. I know that these coordinates will be going up by 4. And this only works as making sure that these x values are going up by 1. As you can see, these x values are increasing by 1. So if these are increasing by 1, what this means is the y's will be increasing by 4. So this is how I would normally do it. I always start with 0 because it's the easiest one to substitute in. If I start with 0, when x is 0, remember? If x is 0, what would y be? Well, let's substitute it in. You're always going to have to do some sort of substitution. When x is 0, what does that say? That says y equals 4 lots of x. Well, we're changing x to be 0, so 4 lots of 0 minus 2. Well, what is 4 times 0? 0. Take away 2 is minus 2. 0 minus 2 is minus 2. So the y value here will be minus 2 when x is 0. So let's just, for clarity, do 1. We'll put 1 in, and then we'll see if our understanding is correct. We'll check, once we put 1 in, is this in fact going up by 4? And if we can spot that that is the case, then we can simply add on 4 or take away 4 to fill in the rest. So if I put 1 in, that means 4 lots of 1 minus 2. 4 lots of 1 is 4. Take away 2 is 2. So that means 1 for x would give us a y of 2. Well, is our hypothesis correct? Is our pattern correct? Yes. What is the difference between minus 2 and 2? Plus 4. And that plus 4 links perfectly with the 4 in front of the x. So now we can be lazy. Once we've established that we've got it correct and it's working, we can just add 4 on now. So if we add 4 on, what are we going to get? 2 add 4 would be 6. 6 add 4 would be 10. And again, I cannot stress this enough. This only works if the x values are increasing by 1. If these x values are not increasing by 1, you can't use this technique and you'd have to substitute in the values separately. So how do we get these ones down here without having to substitute in -1? Well, if this is going up by 4, to go down we must take away 4. So -2 minus 4, well if I'm at -2 and I take away 4, it's going to get me to -6. So we have -6 here. And if I take away another 4, it's going to get me to -10. So that is a method where you can work out the rest of the table coordinates once you've found out 1. And I always start at 0 because it's the easiest one. Once you've found this one, you can check what's this sequence going up by? What's this line increasing by? 4. Going up by 4. So you can just add 4, take away 4. So we've got coordinates now. We've got -2, -10, -1, -6, 0, -2. Just going to rub that out or move it even. Then we've got 1, 2, 2, 6, and 3, 10. Good morning, Lila. So, what can we do here? We can plot them. As always, on the graph, plot y equals 4x minus 2. In between the lines, x is -2 and x is 3. What does that mean? That means it just needs to make sure our line spans across the whole page. And we can just start to plot our coordinates. The first one is -2, -10. So start at 0, -2, cross to -2, down to -10. So our first point is going to be down here. The next one is -6, well, -1, -6, sorry. -1, -6. So across -1, down -6. We're going to get a nice point here. The next one is 0, -2. So across 0, down 2. So across 0, down 2 would give me this point here. And again, it will itself, you can see whether this is going to work or not work. You can see whether your coordinates are in a straight line. If your coordinates are not making a straight line, it means you've done something wrong in the table and that you need to go back and check and double check that you are not making any silly mistakes. Well, next one, 1, 2. What does 1, 2 look like? Across 1, up 2. Across 1, up 2. So it's going to be there. The next one, 2, 6. Across 2, up 6. Across 2, up 6 is going to be there. And the last one is 3, 10. So across 3, up 10. And we can see again, we have made a perfect straight line that we can connect with a ruler. Okay. So connecting that with a ruler gives you a perfect straight line. And what is the equation of this line? You should always label your lines, as I spoke about in the last lesson. That is y equals 4x minus 2. Okay. So here we've managed to speed the process up a little bit by finding one value of x and then realizing it's going up by 4, banging those numbers in, making our coordinates and plotting them. This question has a third part to it, and the third part says use your graph to find y when x is 1.5. Okay, when x is equal to 1.5, what is y? And we have to use our graph. Well, what does that mean? So we want to know the y value. So one of these values when x is 1.5. Well, it's quite straightforward. Where is 1.5 on the x-axis? Hopefully you can see that 1.5 on the x-axis is here. this would be 1.5. Okay? And I need to use my graph to find out what y is. Well, what you do is you have to go from the x-axis and draw a line to meet your line that you've drawn. So if I draw a line to meet our line, it's going to meet there. Then you go across to the y-axis. Boom. What is y? 4. And you have to show that you've done that. So you have to actually get your ruler, draw a line that meets that line. Okay. And then draw a line across, a straight line across. And what we're doing here is showing that when x is 1.5, okay, because it's on the x-axis, y is 4. Okay, when x is 1.5, y is 4. So we could say that here, for our answer, y equals 4. And that is quite straightforward, quite obvious. And hopefully you can see that. So it's a case of using your line to show this. You find 1.5, you go up to the line, you go across, and you get 4. Okay, so this takes us on to our last example, where I've asked us to complete the table for y equals 3x minus 2. Oh, sorry, 3 minus 2x, I should say. Well, immediately, this is different. If we look at our previous equations, we had y equals 2x plus 2, and we had y equals 4x minus 2. So if I was to ask you, why are these different? What makes these different? This new line in example 3 has a negative x. These ones are positive, 2x and 4x, they were positive. This one has a negative 2x. Okay, instead of a plus 2x or 2x plus 3, we've got negative 2x. So we're going to see what happens when our x is negative. So, same principles apply. Always start from 0. It's the easiest number to substitute in to our equation. So we're going to do that, and we're going to show it. We're going to take x as 0, and we're going to bang it straight into the equation. So that says y equals 3 minus 2 lots of x. Well, remember, we're replacing x with 0. So that is 3 minus 2 lots of 0. Well, 2 lots of 0 is 0. So 3 take away 0 is 3. So that means when x is 0, y must be 3. When x is 0, y must be 3. Well, we can use our technique now. We know this sequence, what's happening to this sequence. How could we get these y values without having to substitute in all of these x values like we've just done? Because that takes a while. Well, what is in front of the x? In front of the x is minus 2. So that means that this sequence is going down by 2. We're going to take away 2. So how would I get this value here? And remember, huge caveat to all of this is this only works if the x values are increasing by 1. And as you can see, the difference between all of our x values is 1. So we can use this technique. Minus 2, it means I need to take away 2 from all of my y values to work them out. So if I start at 3, if I take away 2, that would get me to 1. Let's check if that works. If we actually took 1 and substituted it in, let's check if we do actually get 1. 3 minus 2 lots of x, which is 1. 3 minus 2 lots of 1 is 2. 3 take away 2 is 1. So it does actually work. But as you can see, I got it a lot quicker than having to do what I just did by substituting it in. So again, I can take away 2. I can take away 2 from 1. 1 take away 2 is going to be negative 1. and I can take away 2 again. So minus 1, take away 2. If I'm at minus 1 and I'm minus 2, it will get me to minus 3. Now the same rules apply. When I'm going backwards, instead of taking away 2, I'm going to have to do the opposite. I'm going to have to add 2. So 3 add 2 would be 5. And 5 add 2 would be 8. So as you can see, I can quickly fill those in. Let's just take this minus 2, for example, and just show you that you would actually get 8 if you inputted it into the equation. So we've got y equals 3 minus 2 lots of x, which we're going to change to minus 2. We've got 3. Well, what is minus 2 times minus 2? A minus times a minus is a plus. So that would be plus 4. And that would actually give us 7. So hopefully you can spot that I've added 3 by accident instead of 2. Remember, I should add 2. 5 add 2 would be 7. So good job I did check, because I proved myself wrong there. That should be 7. For some reason I added 3. Probably because I accidentally looked at that there. It's actually 2. I need to add 2. 5 add 2 is 7. And if you spotted that mistake that I just made, well done. It means that you're understanding what's happening. But as you can see, that if I did actually do the correct thing and added 2 instead of 3, I would have got the perfect answer. Okay, so all of these y values are changing by negative 2. They're all going down by 2 because we've got minus 2 in front of the x. Well, we've got coordinates now. Let's plot these coordinates. We've got minus 2 and 7, minus 1 and 5, 0 and 3. Let's move this arrow down. We've got 1 and 1, 2 and minus 1, and 3 and minus 3. So we can go to our table again, same story. They want us to, and it's always like this, they'll always give you a table, make you do the coordinates and then plot them. And again, they want it from minus 2 to 3. What does that mean? It means it wants to go from minus 2 on the x to 3, so it needs to span the whole width of this graph. So our first coordinate is minus 2, 7. So start at 0, go across minus 2 and up to 7. So it's going to be the one right in the corner at the top. It's going to be that point there. Next coordinate, minus 1, 5. Minus 1, 5 would be across to minus 1, up to 5. Bang. That one there. The next one would be 0, 3. So start in the middle as always. Across 0, up 3. And you can see, as always, you can see this is starting to create a straight line. If your coordinates are all over the place, so if I didn't spot the mistake I made a minute ago, where I had 8 instead of 7, I would have seen that it wouldn't have actually fitted on my graph. It would have been there, and that is not a straight line. So I would have actually noticed my mistake now when I was plotting them, which is really crucial with straight lines. They correct themselves, you can check instantly. The next coordinate would be 1, 1. So across 1, up 1, so just there. 2, minus 1, so across to 2, down to minus 1, so there. And the last one would be 3, minus 3, which would be that point there. And as you can see, we've made a perfectly straight line that we can connect with a ruler through the points to create our straight line, which was called y equals 3 minus 2x. Now, if we just pause for a moment and we look at, because I said this is going to differ because we had a minus 2x instead of a plus 2x. How is this graph different to the previous two examples that we've looked at? If I just flash between the two pages, that line looks like this, and this line looks like this. Hopefully you can see instantly that this one's going up and this one's going down. And the only factor that's making that happen is because this is a minus 2x whereas this one is a plus 4x. So what we can see here, hopefully we can spot a bit of a pattern, and we're going to go very much into detail about this, because this, and we might add this note actually, a negative x makes the graph go down. Okay, and a word that we're going to be looking at in lessons to come will be a gradient. Okay, this is a gradient. The gradient of a line affects whether it goes down or up. So we can see here that a negative gradient makes the line go down, and a positive, if it's positive in front of the x, a positive gradient makes the line go up. But we're going to look at that in much more detail in lessons to come. So if we finish with part 3, it says use your graph to find x when y is 3. And this is very straightforward. You find 3 on the y-axis, which is in fact right here. Okay, 3 on the y-axis is right there. Usually you'd have to, if I was doing -1, I'd have to draw a line across and then up. Well, what can we see here? When x is 3, what's the y coordinate? Sorry, when y is 3, what's the x coordinate? 0. It is at 0 on the x. So we can say x equals 0. If we do another one, just so you've got some nice notes in your folder or book or wherever you're putting these, we can see what would happen if I wanted y is -2. So find x when y is -2. Well, if we find -2 on the y-axis, it would be right here. -2 on the y-axis is right there, so we can draw a line that goes across to meet our line that we've drawn, and then up to meet the x-axis. So where is it meeting there? That is the point 2.5. Okay, so when x is 2.5, it is because y was -2. So they said -2 to go across on the y, -2, and then up, and it tells me that x equals 2.5 when y is -2, and when y was 3, x was 0. Okay, you can't quite see that, but that's what I've written there. Okay, so that would conclude the 3 examples. It didn't look like much, but there's a lot involved there, and there was a lot to discuss. And we're going to bring this and take this on, and we're going to explore more about the equation of this line. But what I've got for you today, or when you get around to it, is some practice. You can use the understanding that we've just been through to practice some questions. Okay, so we've got 3 questions, maybe 4 for you to practice. Use those techniques, review the steps that I've done in this video, and you always know if you're correct. It will always create a straight line. If your coordinates do not create a straight line, something has gone wrong in the table. So go back and check the table. Okay, thank you for joining in. Hopefully you learned something, and I'll see you in the next one.